Hello everyone, I'm Xiao Gang. Okay, in this lesson, we'll briefly demonstrate how to use GameInstance. Because this is very important, but in my demonstration here, there are no cases later, so this demo will be very simple. You can see we've created a new map, right? And a new folder. Actually, you can see many subsystems here. Obviously, this is our subsystem. The one you use most often is the enhanced input subsystem. It should be used. As for others, these are probably the ones the engine uses more often. These here are runtime subsystems. These are all gaming subsystems. Actually, we also have another kind. There is one here. They are either yay. Let me find it for you. It is a special kind of it. It's called Editor YouTube Widget. Let's just find one randomly. It now looks like this. Let's ignore it. Then we can give it a Kevin. Then we give it a button. This is a button under the editor. It is very special. Let's drag it over. Then we won't give it any text. We need to make this place a variable. Then when it is clicked, you might ask why it suddenly jumps to this. You'll notice this point also has a word contents. This is a very interesting thing. Okay, let's run it here. You will see, right? It runs in the editor. Actually, this tool is the same as these other tools. One advantage is that it can call editor-specific functions and features within the editor. So here we have the subsystem, and you will see there are many more. Right? You can see we can find some that have n in them, and then many of these functions are editor, mainly editor ascend. You can see here, we can see here you can with some methods. These methods are used to operate these assets. These assets are the ones here. Then pay attention to this path. You need to do it manually. This path, the writing of a path is quite special. So this is it. The power of subsystem. Obviously, it is, you can see the editor subsystem, right? And this place can explain in detail the asset path to you. You can see this asset path. Actually, when we encounter this here, let me explain it. You see, this path is the one we often use for load object. And in its second objective lens, it is actually like this. Okay, well, I won't go into detail here. This belongs to Slate and BNDC development content. It shouldn't be discussed here. But you can know. If you want to do BNDC development, there are several subsystems that you must know how to use. For example, this editor, Accept Subsystem, and this editor, Editor Actor Subsystem. Obviously, this actor is used in the editor to handle our level blueprint. If you want to do some manual generation of arrays of actors, right, then you can use this subsystem. There's absolutely no problem with that. You can see, let's just call it subsystem directly. That's it. Then you can go here to, for example, copy, right? Here, you might need to see what specific functions and methods there are. It's also exposed. You see, right here, directed actor. You can look at these things. They are actually all Union AD. Let me tell you a common mistake. Many people like to include this Union AD. Well, congratulations, you included it. Then your packaging will fail. Because Unreal Ed, it is a module that will be stripped during pack. You can take a look at the definition of this module. This is a mistake most beginners make. So if sometimes you absolutely must include this Unreal ED, then how should you do it? Actually, it's very simple. You can write a plugin, and there's a module in this plugin that is used under the editor. Then it's fine for you to use it. And be careful to wrap it with macros like ifEditor. Then in the main game module, you need to distinguish If it is current, list currently in the editor, then include Unreal Ed. If it is not currently in the editor, then do not include the Unreal Ed module. Then this problem can be solved. Okay, let's take a look at this lesson. I'm expanding a little bit for you again. Okay, we'll delete it here. This part is no longer needed. Okay, now let's write our subsystem. First, we still have a work actor here. We'll probably use this actor to access it later, because the subsystem actually spans levels. GameInstanceSubsystem. We are mainly talking about GameInstanceSubsystem here. It can store some data when crossing levels. It works like our game instance. We have already emphasized this again. When you cross levels, your game classes will all be destroyed. Regarding this naming convention, its suffix is generate subsystem. This way, you can find it earlier, and it's also easier to name. In the middle part, it is a description of its functionality. Okay, now we have a subsystem. Go. I'll just write one here. Let's not make it too complicated. Okay. Then let's write it and refresh. Then let's reload. Okay, then here. Let's follow our usual routine. Let's include the header files like this. To avoid some issues. Okay. Actually, its declaration is quite simple. Let's just search here. Let's search for a subsystem. Then copy it over, so we don't have to type it manually. Then you see here, there are also a lot of configurations related to subsystems. But what we are looking for is a substicker of GameInstance. You can see here, most of them are subsystems used under this editor. There is one called mess here. It's for navigation. You can see the subsystem is mass-based. It is a world-level subsystem. We don't need this world-level subsystem. It's not easy to find here. Let's just copy it, okay? I'm too lazy to type this out. If this causes red errors, you can explain the red errors here. Just copy it over. Then, regarding this name, we need to keep it consistent. This name should be like this. See? Starts with U. We start with U. Then here, we write it as the game instance. Okay, then we include its header file. You can see it inherits from USubsystem. It is under these subsystems. GameInstanceSubsystem. We go back here. We include the engine's header file here. Okay. So here we have a class code. So we need to put the brackets correctly. Okay, so this is pretty much done. We mainly focus on this point. So this is the GameInstanceSubsystem. And you can see there is a metadata here. It is abstract. It has a secret API. Okay, this is actually inside the game instance. And we mainly need to write out these three methods. And this part is to control whether to create this GameInstanceSubsystem. We often use some code to determine. That is, if I am on the server, I don't need these. I might not need this subsystem, because this subsystem might be responsible for managing some local user information for the player. For example, the current player, the historical operation records, or the last login record. Then on the server, I simply don't need these singleton. So on the server, we just return a false for it. The server won't create it. If sometimes it might only exist on the server. For example, if the server needs to tally all players' scores or some information, if you want to do some statistics. So when you are on the client side, we return a false to it. That's it. So this part is quite critical. These two are actually just provided for you to override for convenient calling. Okay, let's paste it over. Okay, note that its access specifier is public. Let's go back to this place. And then paste it over. Then we remove this comment. And here, we go ahead and add their implementations. we definitely need to write an alright. Actually, you don't have to write it either, but we also told you earlier why you must write this override. Because I once met a colleague who wrote a method and he didn't write override. And then he said, why isn't this method being called? Or something like that. Because it simply isn't. An overridden method from the parent class. For example, you might write an initialize here. You can tell just by looking. If you don't write this override, you won't be able to tell. Only by writing this override. Only you can tell, right? So why emphasize writing this all white at this point? Then we need to return a true here. Otherwise, it won't have this thing. And then here we write. Sometimes we have the habit of removing this super. Actually, that super doesn't need to be removed. Why doesn't it need to be removed? The reason is also very simple. But sometimes we generally remove it. Yet sometimes it cannot be removed. For example, when we are doing some JS work, you will find that sometimes don't adjust that super, otherwise it will cause a repeated activation situation. Let's first check if the compilation passes. Okay, obviously it doesn't pass. That's because we didn't generate the reflection file. This is also a common reason for missing it. And when don't look at the error list, just look at the output, and this will prompt you the given input is this header file. This thing should not be included here. Let's compile it again now. You can see it didn't include the English library just now. This place shows red because this super is defined in our reflection files generated by UBT and UHT. Okay, so we mainly need to look at this part. You see here there is a GetInstanceSubsystem. Ignore this. Just look at this. You can get this game mode instance. This method of his is very important. And here, because he didn't implement any functionality himself, so it doesn't really matter whether you drop him or not. Okay, good. Then let's write a simple method here. For example, let's call this, this is a player's health status tracking system. So we write a method called AddHealth. Yes, then we pass an instance up. We add a health value, that is in health. In health to add. That is the amount of health to add. Then we might also need a decrease here. So after we add it, there might be a decrease. For the decrease, we use remove. Let's get it first. First, get a shoreline. Let's not write this CRUD. I'm a bit stuck here because I haven't received the specific business logic. It's not easy to make this up. Then here we give it a provide. Then we give it. We initialize. We set this enters. Cancer current health equals 100. Okay, then when we get it, obviously we can make it directly reverse this here. Actually, here you give it. You can write it as force inline. I wonder if I've explained this to you before. Let's search for it. This condition just happens to come up. Force inline. This is, we cancel search. You see? Actually, the engine has many places. It uses this force inline notation. See these places? It's equivalent to when you write very short code like this. You can use this method. It embeds the code into the place you are using, instead of using a function pointer approach. And in force inline, don't write anything too complex. We usually just write 1 or 2 lines of code, and don't write any loops or anything like that. Generally, when we make judgments in Gate, we might use this force inline. That is, when we directly retrieve this value, we might use this force inline. You see, there are actually already many instances of this writing style, and pay attention to observe. We don't need static here, because it actually has an instance. So it's quite different from what we do with Blueprint. You can use our boot here. Here we use second monster. Actually, we can also do some extra operations here. Sometimes we bind some things here, and then execute them, because I don't know who my caller is. I only know who goes. That is, I'm not quite sure. It serves as a bridging role. We'll talk about this bridging concept in the next lesson. In this lesson, we'll just give a simple demonstration regarding this. This involves some of our previous agent knowledge. Okay, let's start it now. Good, we have started it. Then we find our subsystem right here. Yes, here. Good, we have a word. Let's create its class. Yes, let's put it here. Put it here. Then no problem. Good, let's take a look. Good, in BeginPlay. We still use a delay to check. We can input a dash like this. Then double system. We can get it now. Then at this point, we do something simple. We directly let it add health. Let's add 10 points to it. Add 11 points. Then we add another 11 points to it. Okay, after adding, we throw it into the scene. Then here, in our tick, we get our subsystem. Then here, we get health. Then we print it out. When printing, we give it a key here. We can give it a key called Excel to avoid duplication. This way it's easier for you to see the effect. Then let's simply print this effect here. There's an error here, right? Let's check what the cause of the error is. Let me check what the cause is. The cause of the error is simple. Because we wrote office here. Sorry about that. This part was pasted a bit too much, and I didn't check it after pasting. You can't make it abstract here. If you make it abstract, it won't actually be instantiated. Yes, now let's take another look. Sorry, I didn't record it just now. It didn't record, but it's okay. Let me explain again. Right here, we remove the abstract from this part. After removing it, we can use it normally. Then what we see here is actually this part here, right? Because obviously we add our actor twice in BeginPlay. So here it's added once, and then in this, let's change it to after 1 second. We add it again. Okay, actually there's no problem at all. This way it's clear to see after 1 second. Yes, so its advantage, you look here, it's actually the same as our game mode, game state, but actually it is different because it is essentially a lower level replacement for a game instance. First, it has a syntactic sugar design. It looks like this. Actually, if you switch levels, all the things on your right side will be destroyed. However, the game instance, this globally unique instance, it is still here. Then we copy this level. We just press Ctrl+C and Ctrl+V. Just copy it. After copying, well, it is still like this here. Still like this. Then we are here, we press this one. Press 1. We switch by using references. The advantage of switching levels by references. This is a soft object reference. This way, when it is packaged, this level can be brought into the package if you switch using this method. Sometimes you might miss your level. So how do you solve the problem of missing levels? You can force it into the package in project setting. That works fine too. So obviously, we're now on the first level. Pay attention to the object on our right. Okay, now we are at 182. Then I switch levels. See that it added once more on top of 122. It's because in your scene, we are now observing this live subsystem 1. So that's how it is. We can demonstrate it again, because this is quite important, even though it's just a simple demonstration. The things it contains can sometimes, for beginners, they might not grasp this point at first. They just don't know how useful it is. Let's switch over. Hey, right? Now it's 144. Okay, we'll stop the demonstration here. This is a simple process of calling and using something in Blueprint.